In this lesson, we're going to do long division with polynomials, which can be a little bit tricky, so it's best to get your technique right, doing something a bit easier first, like working with integers. Now, you might have done long division in primary school. They certainly used to hammer that when I was a kid, and we all learned how to do it, especially when we were dividing by two-digit numbers. But it's not taught quite as commonly now, so it might be new to you. So, what's the difference between long and short division? Well, short division is where in both of them we draw up an algorithm like this. In short division, we put our remainders just as little numbers in here, and then we work through. In long division, we end up with a whole bunch of stuff down here where we actually work out our remainders as we go. So let's look at the difference. If I'm doing this with short division, I say 2 divided by 22 doesn't go, but 26 divided by 22 is 1, remainder 4. 45 divided by 22 is 2, remainder 1. 18 divided by that doesn't go, but 182 divided by it gives me, 8? And I know that 8 22s is 176, so there's going to be a remainder of 6. Now, to do the same thing with long division, we have our number still in here exactly the same. We say 26 divided by 22 is 1, and then we say, well, what is 1 lot of 22? I did that in my head before, but this way we write down 1 times 22 is 22. Now, if you're multiplying a single digit number here by a two-digit number there, and it's something that you have to do some carrying with, then you can, of course, treat it as though you're performing a separate algorithm. You'll probably see that better as we go. At this point, you say, well, what are the leftovers? If 1 lot of 22 is 22, and I had 26, then the leftovers would be 26 minus 22, which last time I did in my head and got 4. But this method says, let's set it up like a subtraction algorithm and take our time in case there's carrying to do. So we can see that 26 minus 22 is in fact 4. All right, what did we do with our 4 last time? Well, we had it knocked in here, didn't we? And we said that this was 45. Well, the same thing needs to happen with the long division method, except that we need to bring this 5 down to join the 4 down there and turn the 4 into 45. Now we can say 45 divided by 22, just like we did before, and that gives us 2. And notice that I'm lining things up in a particular way. Now, what is 2 lots of 44? What's 2 lots of 22? It's 44. And what's the remainder? Well, again, I can do this in my head, but all set out like this, I can see that 45 minus 44 is 1. So I've got another subtraction algorithm here. Now, last time I had that 1, I just put it in there and made 18 with it. We're going to do the same thing here. We bring that 8 down, and we say 18 into 22 doesn't go. But what we did next is we brought the 2 into it, and we said 182 divided by 22 is 8. And then when we did the 8 22s, that was the part where I had to think a tiny bit harder because there was some carrying to do. Well, exactly as you would do this by saying, let's put 16 and then 2 8s plus that to get our thing there, you can do the same thing here. So you've got 8 2s is 16, and I carry the 1, and 8 2s, I get my 17 like that. So you can use your working space, I suppose, to come up with sections of the puzzle so that you don't have to hold everything in your head at once. So down here I can subtract these and say that the remainder is 6, and so then I can write it on the end like that. Now, if you just watched that demonstration of short and long division with the same question, and you're thinking you can keep your long division, the short one looked fine to me, hold up a minute, because when we are working with dividing polynomials, all of this setting out that we do for the long division method is really, really helpful. And the reason it's helpful is that we're going to have something here to divide by that is a bit complicated and has 2 or maybe even 3 terms in it. Now, you could think of this two-digit number as being something with 2 parts, a 20 part and a 2 part. And you can see that when I multiplied by something a little bit complicated, there was some thinking involved. Well, that complication factor is going to be heading upwards. So this setting out's important. Now let's look at some key terms and ways that we can set up this result for this question that we just completed. So the dividend is the name of the thing that you're starting with, the thing that you want to divide up. And the thing you're dividing by is the divisor. That makes some sense. The quotient, this is a word that you would have come across before, and it probably reminds you something to do with division. Well, the quotient is effectively the answer to that division problem. And you may or may not have a remainder. You'll always have these three parts in a division problem, and you might also have a remainder. So 2 ways that you can set this information out, well 3 really, because this is clearly another way. We can say that if we're looking at that number that we started with, the dividend, then clearly it must be, in this case, 22 multiplied by 1208, or the divisor multiplied by the quotient, because if we multiply these together, we'll almost get that, but not quite, because there was a remainder. So if we then add that on, then we'll have the full total. Now, if you don't have a remainder, then obviously you can leave that off. And so if you had a much simpler example, let's say that we were just doing 12 divided by 4 equals 3, then we could say that 12 equals 4 times 3. Whereas if we were starting with something a little bigger that gives us a remainder, then we would say that 13 equals 4 times 3 plus 1. So a nice simple example there, the example we've already used, and an example that's using the new key terms that you need to learn. Now, rational form just deals with the remainders in a slightly different way. Let's have a look at it with this simple example. Let's imagine we've got 13 pizzas and 4 very hungry people. They can easily get 3 pizzas each, no worries, but there's going to be 1 remainder pizza that's left over. And if they're very hungry, I bet they're going to suggest cutting it 4 ways and splitting it. They're going to get a quarter each. So we can say that 13 divided by 4 is 3 and a quarter. And another way of writing that is 13 divided by 4 equals 3 plus, it also equals a quarter. Now I'm keeping that quarter and the 3 separate for a reason so that we can really see what's happening here. With our more complicated version, we divided this large number by 22 and we got 1,208 plus those 6 remainders could have been divided by 22 as well, and that would give us 1208 and 6/22. Now I could simplify that into 3/11ths, but I'm not going to because I'm going to keep these numbers really simple, looking the same as they were here, and so that we can do the dividend divided by the divisor, and that will give us the quotient plus the remainder over the divisor. Now, don't try to memorise either of these like lines from a play. You need to just understand them. And the easiest way to understand them is to keep a really straightforward example in your mind or to reproduce it whenever you need to so that you can generate these forms as required.